Hey, what's going on, guys? So, what I got here today, I'm going to be making this cheap fog machine that I picked up at a local Goodwill for about $7. Um, Everything works on it. I think the only reason they got rid of it is they weren't using it or they lost the remote to it. Because without the remote, this fog machine will not work unless you manually jumper these pins over. But what I want to do with this is make it DMX controlled so that I can fire this fog machine remotely from X-Lights or Vixen over Wi-Fi. So we're doing DMX over Wi-Fi. Um, and I want to be able to activate this fog machine from the computer without having to manually turn this on or go, do any kind of oddball stuff. Have it running throughout the entire show, which would just waste fog, and it'll allow me to cycle it on and off to save on the liquid fog. So the operation of these fog machines is pretty simple. It's actually quite ingenious. There are no active electronics in here. All this is kind of just mechanical. So we'll go through the electronics real quick and then we'll go through how we're going to control it. So we got power comes in down here. Power goes up to the switch, which is back here on the back of the unit. From the switch, part of it branches off to this remote port here. It's this 3-pin connector in the back. The top pin of this port will be 120 volt line voltage. The second port down is the remote port, or what you need to short to activate the pump. And then the bottom of the port is the neutral coming from the switch on the back. So power comes in from the switch. When you activate the switch, it'll run through, the line voltage will run through this little temperature switch on top. This is normally closed, so it'll pass current to one side of the heating element coming down into here. And then the other side of the heating element is neutral that's tied to the switch. So when you turn the switch on, it'll pass both line and neutral to the heating element. The heating element will start to heat up. When it gets to a predetermined temperature, this temperature switch opens up, which disconnects the line voltage from the heating element and allows it to cool off. So that's important so that you don't have runaway heating of your heating element, and it allows to keep it within a good temperature range. The pump is powered off of 120 volt. The line voltage comes off the same line voltage that's passed through this temperature switch. So when this switch is closed, it's also passing line voltage to the pump. The neutral side of the pump is only activated through this port in the back. And this is black wire that you see here. So to activate this pump manually, you could just jumper over the middle pin and the bottom pin. At least on this unit, your unit may be different. But the middle pin and the bottom pin will complete the circuit to the pump. And once the heating element reaches its desired temperature, the pump will turn on. It'll continue to pump fluid into the heating chamber and produce fog. As it produces fog, as it burns that fluid off, it will lose temperature. It'll get cooler. So as temperature drops, this switch will close again. The heating element will go back into its heating mode, and it'll continue in that cycle. So what we're going to do, I'm going to use a Wemos D1 Mini, just because I have a bunch of these laying around for other stuff that I've used on Christmas lights, and just a Wemos D1 relay shield because it's nice and compact. I'll put a link down to the Arduino sketch below that will allow you to convert DMX data over Wi-Fi to a single channel. And we'll go over the software here in a little bit. So I'm going to use a Wemos with a relay to trigger this input. And then I have a cell phone charger that I ripped apart to scavenge this 120 volt AC to 5 volt DC power supply. And this is what's going to give me my 5 volts to the Wemos. So both of these will be put into an enclosure. And then the only modifications that we're going to do on the fog machine is disconnect these 3 wires going to the remote port. So the line and neutral will power this power converter here that gives me my 5 volts, and then the neutral and the pump remote switch or remote line will go to the common and normally open contacts of the relay. So let me get this camera changed around. I get my laptop in here. We'll go over the software and then we'll get a little deeper into building. Okay, so here we're looking at the Arduino IDE. I'm just going to quickly run through the sketch that's going to be used on this. So this original sketch was produced by Shelby Merrick. He's the same guy that produced the ES Pixel Stick firmware and all of its subsequent revisions, and it's at the forkandeye.com website. So this is his base code, and then I just modified it for use with relays. The original code was designed to take E1.31 data in and then send or control a string of pixels off of like a Wemos or the ESP8266 base models, the ESP01s, all those variants. So this is modified slightly to be able to use relays, and like I said, I'll put a link to the code down in the bottom. So here we put in our SSID and password. So this is going to be for your show network. Here we're just defining what channel we're going to use. So this is going to be channel the green or color green in the DMX data, and it's going to be channel 1 is what I'm going to be using. Here we set the output for the controller. On mine, since I'm using the Wemos D1 Mini and the associated relay shield, it's going to be on pin D1. It goes to that one relay. So this section of code, we are looking for E1.31 data, and it will open up a serial monitor and serial print any data that it sees. And then later down, we select either unicast or multicast. I have mine set to unicast. And then here we set the output pin or the pin D1 to output for the relay, and then we command it low. This will change depending on the type of relay you're using. Mine, I want the relay to be deactivated upon power up, so I'm going to send it low. Some of the relay boards that you can purchase, this will have to be set to high as that logic is inverted. So we go down here. Here's where it looks for the E1.31 data and collects it, stores it into essentially a register, and then down here is where we output that data that it was received. So here we're saying if the E1.31 data channel 1 green, the value of it, which runs 0 to 255, is above 200, and this is to prevent false signals. If that signal is above 200, then we're going to activate the relay high. If it goes below 200, we're going to turn the relay low. So this will ensure that when I'm commanding this universe and this channel, channel 1 or the color green, to say a max value of 255, the relay will turn on. Anything below 200, like 0 or anything up to 199, the relay will turn off. And so that's it for the software. So let me get this zoomed out. And I have my Wemos D1 Mini powered up here, and I ping the IP address so I know what address it's on. There's also a nice little widget that you can download. I'll also link it below. It is a third-party open source DMX tester. E1.31 Test Source is the name of it. It's free to use, free to download, but if you can, I would say donate to their page, because it's an awesome little tool, not only for this particular project, but anything dealing with E1.31 or DMX data, just to be able to test offline without having to connect to a Falcon Pi player or to another Falcon controller or your Wemos, Sandvik discs, whatever. This will allow you to just punch in the IP address of whatever target device you want to test, and then you can manually command as many channels as you need to check to make sure that your colors look right, or that the device that you're wanting to control is working as it's intended to. So down here I set the IP address of my device, which is .106, and up here in the channels I'm going to limit the channel range to channels 1 through 3. And I'm connected to my network. I know my device is connected. So now, with my little Wemos, when I bring the slider for the color green, okay, so here we have this E1.31 test tool. This is the COM port for the Wemos, and then this is the channel data display that this little tool provides so that you can see the output of each channel. So you can see as I raise the percentage of green, we'll see this number start to climb over here, and then we'll see this number start to climb over here on channel 1. And as soon as it hits above 200, our relay turns on. We get below 200, the relay turns off. And so that's what we want, is to be able to hook the remote port of the fog machine up to here, and then when we drag, just say, the on effect in X Lights or Vixen over to our sequence, we set it to the color green, and we set the intensity to 100%, the fog machine will turn on. When we command it to, or set it to 0% brightness, or set it to off, the fog machine will turn off. So this gives us remote capability of the fog machine over Wi-Fi. So that's it for the software side. Let me get all this stuff clear off the bench, and we'll get this installed in the enclosure on the fog machine, and then we'll head outside and test it. Okay, looks like I got everything just about tightened up. Got everything in the enclosure. I got the unit turned on and warming up. So here's the enclosure I went with. This is the 120 volt to 5 volt DC converter, and this is my Wemos and my relay board kind of stacked in there. And then I had a cable gland come over here. This goes inside the unit, which connects to these 3 pins, which provides me 120 volt AC to my converter, as well as the remote terminal that goes to the pump, which I have on the common and normally open contacts. Switch the unit around here. I went ahead, I was going to originally just cut and solder these, but I went ahead and put spade connectors on them, because spade connectors were on these 3 wires that were on this terminal inside the unit originally. So I went ahead and put spade connectors on there, and then threw a piece of shrink tubing over it. So if I wanted to revert this thing back to use the remote pendant, it's as simple as unplugging these 3 wires, plug them back into the port, and we're good to go. So we'll let this thing get warmed up, and then we'll test it. So we'll be back in just a minute. Okay, have the unit powered up outside. I had to move it outside just in case I don't smoke my garage out. I got my laptop hooked up. It's already connected to the Wi-Fi. So now we're going to come in here and hit raise essentially the brightness of the green color to 200. It activates our smoke machine. We toggle it off, smoke machine turns off. And we can toggle it on, toggle it off, and there we go, a DMX controlled smoke machine. If you got any questions, please post them below. Any comments, also post them below. If you haven't subscribed yet, please hit that subscribe button. I try and put out videos as soon as I can, or usually about once a week. Other than that, we'll see you next time.